When it is switched off, it again dims. Or it would have happened with you that you accidentally touched the open electric socket at your home and then you get an electric shock, right? So what do you think all these are caused? So these are all nothing but what we say in our layman terms, that electric current, right? So current is something which we are going to study in this lesson. So you can take many more examples where these things play a role. For example, your battery, which you use in many of your electronic devices, as well as you would have seen inverters in your home, right? So those batteries are also an application of this current flow or charge flow. The computer, your desktops, the electric fans, your television, mobile, everything which you see around yourself, all electronic and electrical items which we see around you are nothing but applications of what we are going to study now. So this lesson, in the previous two lessons, we studied about charges. What is an electric charge? What are the different properties of charge? So we studied about static charges, that is the scenarios where the charges were at rest. Now we will look at the scenarios or the phenomenon which take place when charges move. So what happens when charges move? It gives rise to electric current. Current is a word which we normally use in our day-to-day life, right? So in this lesson, we will study electric current in detail. We will see different properties of electric current, what gives rise to electric current, and many other things. So at the end of the lesson, we will also solve some problems based on the same. So let us start the lesson with what is electric current. As I just told, electric current comes into picture when I talk about charges in motion. You already know what are electric charges, right? So as long as we imagine that my charge is at rest, it is not going anywhere. So we talk about electrostatics, that is the charges, the branch which deals with the study of charges at rest. The moment I talk about charges moving, when the charges start moving, we no more talk about statics, we talk about dynamics. Now, the flow of charges constitute electric current. So electric current is nothing but when charges flow, electric current is set up. Very simple, right? So how do we basically measure electric current? How do I know how much electric current is flowing through a particular wire? I know that all of you are aware of what a current is or in what context we use current. We often say, right, say, for example, let us suppose your mobile phone charger, you have plugged in to the switchboard. You say that now when your mobile is getting charged, you see that current is flowing through this wire, right? So that means there has to be some parameter which will measure current. How will I measure current? So current is basically measured as the rate of flow of charge. So what do I mean by rate of flow of charge? That means how much charge is flowing with respect to time. So let us suppose, if I say how much amount of charge, if I say, let us say 10 coulombs of charge had flown in 1 second. So we say, what is my current? My current is nothing but 10 coulomb per second. So that is my current. So electric current is basically measured as the flow of charge per unit time. Right? So we can write this as, let us suppose if I denote electric current with I. So electric current is nothing but time rate of change of electric charge. So we can write it as dq by dt. Right? It is generally denoted by capital I. The SI unit of current is amperes, which is denoted by capital A. Like the way we have SI unit for charge as coulomb, similarly we have the SI unit of electric current as ampere. So how do we define ampere and from where does this word ampere come? We will study about that in the next slide. So let us take this simple example. This is a simple circuit which is drawn here. Normally, since we are just at the first slide of the chapter, let me tell you few very small things. Whenever you see an electric circuit which is drawn for you, this represents nothing but the source of voltage. This is basically the source of the current. This will give rise to current. So this is nothing but your battery. This battery is represented in your electric circuit with two lines, a smaller line and a longer line. So the longer line generally denotes the positive terminal and the shorter line generally denotes the negative terminal. So this is your battery, which is the source of your current, right? What is this? This kind of symbol generally denotes a key, or which you can say as a switch. If the key is in this position, that means the switch is right now off. That means there is no current flowing through the circuit. For example, this bulb is attached in this circuit. When will the bulb glow? When you switch it on. When you switch on the circuit, then the current will flow, right? Right now the switch is open, so there is no current flow in the circuit. Now as soon as the key is pressed, as you just saw, the key is pressed, so your circuit becomes a closed circuit. So the current flows through the circuit and the bulb glows, right? This is what basically, this is what happens in a basic circuit. You switch on the key. I just told you how we represent a key, how we represent a battery source, so that you don't have issues when you go ahead. But because as we go ahead, we will draw more complicated circuits, right? So till now, what did I study? I basically studied that electric current is nothing but moving charges constituted. Whenever charges move, electric current is produced. It is denoted by a capital I. The SI unit is ampere. We measure it as time rate of change of charge flowing, right? That is rate of flow of charge. Now,